chicken plow. You tell me what else is on the menu, please, sir, for the
This is a reliable electric 3,000 watt 12 volt power inverter. About all that talk you're going to get out of me. Okay, so they list all the possible voltages and they use a Sharpie marker to fill in which one you've got. That's high class. It doesn't dream of putting out 6,000 watts, which is its rated peak output. This is a 2,000 watt inverter, about 3,500 peak. It's got 4 transformers doing 750 watts apiece, maybe 800 or so. That's about all you're getting out of them. Pairs of MOSFETs driving the transformers, single MOSFETs comprising the H bridge. And that's the entirety of the high voltage rectifier. It uses your cheapo depot SPWM module, and of course the cheapest available everything, while these are undersized, making up combined about a 6 gauge cable. I'll be leaving them alone because I can't be bothered. However, I will be going to great lengths to change the way it runs its fans, because the way they set these up, it doesn't know or care how hot the transformers are getting, and can't be bothered to give them a little airflow. This will be controlling the fans from now on. It uses 6 temperature sensors, 1 for each transformer and 1 for each heatsink. And it controls the fan gradually as it warms up, instead of all or nothing. Not only that, but it'll tell me which part is the hottest. I've got to put this on a circuit board and figure out a way to install it into that power inverter.
Homosexuality, fecal matter, butthole. What else? Oh, that's right. Stupid.
We got our temperature sensors installed in here.
Yeah, what's going on?
Epoxy. We got our display neatly installed into the front panel. Well, it just doesn't get better than that. There that is. And this will just sit on here like so. And there you have it. A fully custom fan control Arduino inverter cooling fan control PC fan cool hydronic pure sine wave success. L293 ICs can't handle those fans. They last about an hour.
Right, I'm getting pissed. I can't find my C batteries.
Now the burned out IC that we had originally tried to use has been replaced by this oversized MOSFET driver.
Penis, crystal ball penis.
Those MOSFET drivers don't give you any control. It's just all or nothing. Fans run all the time at full blast. I've got a pair of PWM fans here, the 4-pin variety that everyone argues over. Some people say you have to have a 25 kilohertz signal to run these, and other people say it'll work fine if you hook it up to the 900 and something hertz signal from the Arduino. I've seen a lot of videos of people hooking them straight to the Arduino, so I'm going to try it. We're going to see if it works.
You say that we have free will? How dare you assert that? Nobody has free will. Everybody's controlled by everyone else. That's how it works.
So now the PWM signal that comes out of the Arduino goes into these two pins, as well as into this little MOSFET driver. There's the new fans in there. They run through these cables right here and they go to the board. That's how that's hooked up. Let's see if it works or not. Regular old PWM 4-pin fan operating off of a 900 and something hertz signal from an Arduino. And it is ramping the speed up and down like it's supposed to, it would appear. You don't need 25 kilohertz. The all or nothing nature of this MOSFET driver has been taken care of with the PWM fans and their special little connector. But the temperature jumps all over the place because those thermistors I used are shitty. So now I have to put a bunch of capacitors on here to try to smooth that out. Now there's a row of capacitors, 100 nanofarad capacitors, because they're the ones that would fit. Capacitors made more difference than I thought they would make. It's now running about an 800 watt load. And it's gradually warming up and gradually ramping up the fan speed, and there's no jumping around. Now running about a 1200 watt load, no jumping around. I decided I need another fan. So I've put a connector right there. These three 100 ohm resistors here are in parallel, connecting it to positive so that I can run this 5-volt fan, which is mounted right there to blow directly on the transformers. Look at this. When that fan's in there, the inverter doesn't work. Even if it's unplugged, still it doesn't work. If I just take it out of there, it suddenly works. I've repeated this experiment a couple of times and I don't really have any explanation for it, but I guess I'll be leaving that fan out. This is the code that runs this thing. It's pretty simple stuff. There's nothing really complicated in here. It reads the temperature sensors and gives them a value from 0 to 99. It decides whether it's heating, cooling, or chilling. Decides what thing is the hottest. Decides what it's going to say about it. Then it sets the fan speed. And last, it shows everything on the screen and then waits for a little while. I've got this hooked up to 32 mil cable. It's American wire gauge number 2. There's a 3.5 farad capacitor parallel to the end of the line to make up for the line being slightly undersized. This is the battery, a single Deca 1000 cold cranking amp, whatever the hell that means. There's an extra 4 gauge cable connecting the alternator because fusible links are pathetic. In this configuration, as long as an alternator is there keeping up, this will do 2000 watts continuous power. If the alternator is not charging the batteries, Maybe you do about 1,000 continuous. I don't ever see anybody running a capacitor when they have their inverter on the end of long wires, but you really do get some improvements there if you do that. The way I program it is with this modified USB hub and its long cable and this tiny puny little cable that the Arduino comes with. If you just open this up slightly, there's the USB port. So that makes life pretty easy. Just as primitive as you can get. There's nothing special about this code. I'm not no programmer. And that brings us to the most important modifications that I did to this. Something I consider absolutely crucial is getting rid of that stupid, intense blue indicator light. Now I got a green one on there. I've got a 100 kilo ohm resistor in series with that LED to make it that dim. I don't know what exactly they were doing to that blue LED. I've also stuck yellow tape over both of these displays. You can see it there, kind of sloppy. Dumbs it down a little bit. Those are too goddamn bright. And last but most important, I took out the buzzer. No buzzing. That beep was the microwave turning on. Yep, that's how you modify a 2000 watt pure sine wave inverter.